Good morning, all. I already told it in the last class. This class, we are going to see about what are the Fourier cosine and sine transform for the different types of the functions. Before we should go to that, what is Fourier cosine and sine transform for different types of the functions? First, we are going to see about what is the definition for Fourier cosine and sine transforms. Now, you see that the f of x function is defined for all positive values of x. Defined for all positive values of x means we are defining in between the range between f of x is defining in between 0 to infinity. Now, if f of x is defined in between the f of x as a function, we are defining from 0 to infinity limits, then what about the Fourier cosine and sine transform? You see that the Fourier cosine transform of f of x is equal to 0 to infinity f of x cos ux into dx. What is infinite Fourier? What is that here? Fourier inverse Fourier cosine transform is this f of x comes outside now. Now from that we'll get a 2 by pi into 0 to infinity fc of u cos ux into du. At the same time, Fourier sine transform is the same thing, into 0 to infinity f of x sine ux into dx. Now, infinite inverse Fourier sine transform is the f of x comes outside, which becomes 2 by pi 0 to infinity fs of u sine ux into what we get now. Okay. Now we are going to see about what are all the different types of the functions. For the functions, how can you find out the Fourier cosine and the sine transform for the different types of the functions? We are going to see now. You see the concept over here now. Find the Fourier sine and cosine transform of f of x equals tx where x is like to 0 to 2, 0 for other things. Now this is a discontinuous function. How can you find out the Fourier cosine and sine transform of the function? Now you know that Fourier sine and cosine transform for the function can be written as fs of u is equal to 0 to infinity f of x sine ux dx, and fc of u is equal to 0 to infinity f of x cos ux into dx. Now from that, what we are going to phrase from this means here, from this now, fs of u. First we are going to see about Fourier sine transform. Fs of u is equals to, now you see the limit 0 to 2 here, that's why 0 to 2 in between the function f of x is equals to x into sine ux dx. Applying the Bernoullis. You know about the Bernoullis integral u dv, integral uv dx, which is equals to uv1 plus u dash v2 plus u double dash v3. That's why this becomes x becomes u and uv1. v1, the differentiation of the integration of sine ux becomes minus cos vx by u plus again uv1 plus u dash v2. That becomes x differentiation 1. The cos ux differentiation minus cos ux integration becomes plus sine ux divided by u. So this one already know about. Now you are substituting the limits for x is equals to 2 here for the first term, minus 2 into cos 2u by u. At the lower limit becomes 0 plus here sine 2u by u square minus 0. Now you got sine 2u minus 2u cos 2u by u square. This is for your sine transform. Cosine transform, the same thing we are applying over there here. Just substitute what is that here x into cos ux into dx. Automatically what we got, now only I'm just saying this is an easy concept, that's why I put some dots over there here. Now x into cos ux becomes what is that here sine ux divided by u plus u dash becomes 1. Sine ux becomes what is that here minus cos ux divided by u square. On simplify we got 2u sine 2u plus cos 2u minus 1 divided by u square. Okay. Now we are going to see about the next concept over there here. Find the Fourier, just only for a cosine transform for the function f of x becomes 4x where x is from 0 to 1, 4 minus x from 1 to 4, and 0 from x is greater than 4. Now we are going to write about what is cosine transform formula. fc of u 0 to infinity f of x cos ux into dx. Substituting the limits 0 to 1, 1 to 4, and greater than 4 means we write it as 4 to infinity. You see that. Now we are substituting the functions for it. Now we are getting the three types of the functions, so that we are applying the Fourier cosine transform for that. Here take the 4, here 4 minus x is already there. Now here also same thing, u x into cos ux. Okay. Now x into cos ux means what we get now here. Now first we see that u into what is that here, what we have to say from this means here. Now first you see that I just mentioned for you. Now this is u and this is v1 minus this becomes u dash. U dash becomes the x differentiation becomes what you get now 1. U dash into what is v2 here, cos ux divided by u square. Now minus into minus becomes what you get now. We got what is that here, and now plus over there here. Understood? Okay. Now after that, here also the same functions we are using now. Here also the plus is that here. Now 4 minus x is u. Here cos ux, what is that here? V. The same formula we are also applying u v1. Now this is u and this becomes what is that here v1. This becomes minus u dash into what we get now v2. Now after that, what we get substituting the limits. So this is very easy concept. This are already known about that. X is equals to 1, x is equals to 1 for the first term. This becomes 1. If you substitute x is equal to 0, sine 0 becomes 0. Now here this becomes 4 by u square, and this becomes cos u minus cos 0 becomes 1. Plus 1 by u will be subtract the limits. Upper limit 4 minus 4 becomes 0. Lower limit 4 minus 1 becomes 3 minus 1 by u square of this becomes cos 4u minus cos u. So that 4 by u sine u plus 4 by u square cos u minus 4 by u square minus 3 by u sine u minus 1 by u square cos 4u plus 1 by u square cos u. On simplifying, we got it. What is that here? 1 by u sine u plus 5 cos u minus 4 by u square minus 1 by u square cos u. That's what we got it. Okay. Now that's why we find out the Fourier cosine and sine transform for the two different types of the functions. Now move on to what we are going to see. This is one important problem which is related to that. Solve the integral equation f of theta cos alpha theta d theta equals 1 minus alpha where alpha is less than 1. 0 for alpha is greater than 1, hence evaluate the result. Now what we are going to say from this means the right hand side is 2 seaters. What is that here? FC of alpha. Now FC of alpha becomes 1 minus alpha where alpha is from 0 to 1, 0 alpha is greater than 1. Now the left hand side, I am going to find out the f of theta value so that I can substitute the value for the f of theta here. 2 by pi 0 to infinity FC of alpha cos alpha theta d alpha. From that what we get now here, FC of alpha is just to see here this point over there here. I'm just note down for you now where alpha is raised to what is that here 0 to 1. So that's right. That's why this becomes alpha is from 0 to 1, 1 minus alpha cos alpha theta d alpha. Now applying the what is that here Bernoulli's formula, integrate with respect to alpha. This is important now. Cos alpha theta by alpha minus cos alpha theta by theta square. Now 2 by pi 1 minus cos theta by theta square. On simplifying 1 minus cos theta, we know the trigonometric formula 2 sin square theta by 2. We'll get 2 will be cancelled with 4. Sin square theta by 2 by theta by 2 the whole square. Next, we'll evaluate the second result. One thing sin square theta by 2 by theta by 2 the whole square into which is equals to FC of alpha, where theta is equals to theta by 2. It was just 2t to evaluate it. Otherwise, by help of the substitution method, we are going to solve it. Now theta equals to 2t, 2t, d theta becomes 2 dt, and theta varies from 0 to infinity as usual. And substituting, we'll get simplified, get theta because what is that here? Because 0 to infinity, sin square t by t square into t square into dt becomes what we get now? Pi by 2. On substituting, changing that t into x, we'll get the approximate result. The value becomes pi by 2. Right? Thank you all.